Okay, so let's do in class 8. So in class 8, we have two groups of 5 people, and suppose you're in one of the groups. So the experiment or the game is one member of each group gets chosen for what we're calling the winner circle, and then from those 2 people chosen, one of the people is then chosen to win a prize. And suppose that the game is repeated 3 times with the same people, so find the following. So A is the sample space, so let's look at that one. So I'm going to let, for easy notation, say let G1 be defined to be game 1, G2, let's define that to be game 2, and G3, it will be game 3. Okay, so let's look at the sample space. Well, let's also make an assignment here. Let's say, so group 1, we'll say contains the numbers 1, it's the first person say 1, 2, 3, 4, 5. Let's also say that, so let 1 denote you. So you're number 1, say, as group 1, and say group 2. Group 2 then will be, say, 6, 7, 8, 9, and 10. So let's look at the sample space from that then. So sample space, let's call it S. So it's the winner circle sample space. So you could be chosen for winner circle. So you and say someone from group 2, so 6. Could be you, 7, you, 8, you, 9, or you and 10. Okay, so then we could do the same thing. Now instead of 1 in the first position, we could have it 2, say. So we can repeat this, just change everything to 2 here. 2, 2, 2, 2, 2. Then we could have a 3, 3, 3, 3, and 3. And we could have a 4, 4, 4, 4, 4, and lastly, we could have 5 in the first position. So it'd be 5, 5, 5, 5. So this is the sample space of the first round. 5, 10. So that'd be your sample space. So for example, the 1, 6 would mean that you're chosen and person number 6 in group 2 is chosen, and so forth. So this is all the possibilities for the first round, so group 1. Sorry, not group 1, round 1. Okay, so part B now, we have to find the probability that you make it to the winner circle in game 1. Okay, so let's look at that. So probability winner circle in game 1. Well, if you look up here, all the ones that have a 1 in them are ones that you make it to the winner circle. You highlight those. So there's a total of 1, 2, 3, 4, 5 of them. So it'd be then 5, then divided by, and then you count the number in the sample space. So there's 5 there, another 5 there. You can check there's going to be 25 if you count them all in the sample space. So pretty much the number in the sample space is 25. Okay, so this reduces to then 1. So 25 you can write as 5 times 5, and that's going to reduce to 1/5. So the probability that you make it to the winner circle in game 1 is 1/5. So you make it there once out of 5 times. So if it's played 5 times, you make it an average once. Okay, so that's part B. Part C is probability that you win the prize in game 1. Okay, let's take a look at that one. So part C, so probability win game 1. So that you can think of as the probability that you make it to the winner circle. Well, you have to make it to the winner circle if you win the game. And then it's going to be times the probability that you are chosen from winner circle. Chosen from circle. Well, we've already said that the probability winner circle in game 1 is 1/5, so it'll be 1/5. And then times, then the probability that you're chosen from the winner circle. Well, since there's 2 people in the winner circle, it's you and somebody else, the probability that you're chosen will be 1/2. So like this. So therefore there's, multiplying those, it's 1/10 the probability. So there's a 1 in 10 chance that you'll win game 1. Okay. And we're multiplying the winner circle in game 1 times chosen from the circle because they're independent events. Because the probability that you make it to game 1 does not affect the probability that you're chosen from the circle. They're independent events. So you multiply them then. Okay, so moving on to part D, the probability that you win at least one game. Okay, let's take a look at that. So note, the probability that you lose game 1, say, equals, I claim, 1 minus probability you win game 1. So the 1 is saying that event will happen. So the probability that you lose game 1 is equal to 1 minus probability that you win. If you think about that, it should make sense. Because if you take away win, then what's left is lose. Okay, so therefore it'll be 1 minus, and we just said win game 1 is 1/10. So you can write 1 as 10 over 10, then minus 1 over 10. And then subtracting those two, it'll be 9 over 10 is our answer. So there's a 9/10 chance that you'll lose. So pretty much if you played it 10 times, on average you'd lose it 9 times the game. Okay, let's keep going with this. Since let's call it E1, say, lose the event that you lose game 1. Let's call E2 the event that you lose game 2. And E3 lose game 3. I claim are all independent events. because the probability that you lose game 1, that does not affect the probability that you lose game 2, which in turn does not affect the probability that you lose game 3. Just because you lose game 1, that has no effect on whether you'll win or lose game 2. So they're independent events. We have then we have the probability that we lose all 3 games will be equal to the probability that we lose game 1 times the probability that we'll lose game 2 times the probability that we'll lose game 3. And each of these is probability 9 over 10. Because we've shown the probability that you lose game 1 is 9 over 10. The probability that you lose game 2 is also going to be 9 over 10, and game 3 is also 9 over 10. So it'll be 9 over 10 times 9 over 10 times 9 over 10. And that then will equal, so multiplying those, so you multiply the tops, be 9 times 9 times 9. You can check if you multiply 9 times 9 times 9, it will be 729. And multiplying 10 times 10 times 10. So 10 times 10 is 100, times 10 again would be 1,000. 1,000 here, so it'll be 7 over 1,000. Okay? So hence here, the probability that we win at least one game I claim, so at least one game out of the 3, is equal to, I claim, 1 minus probability that we lose all 3 games. Because if you think about it, if you take lose all 3 games out of the consideration, what's left is, so if you don't lose all 3 games, then you have to win at least one game. So when you go 1 minus this guy, you're taking that lose all 3 games out of the picture. So what's left is only, you'd have to win at least one game. So if you didn't lose all 3 games, it would mean you'd have to win at least one game. So we have this, which is nice. So I'm going to continue this question in another video, part 2, because we're out of time in this video. So let's leave it there for now.